Supervised classification is better to use if we know where particular land covers are in an area before we start our classification. So basically those areas that we know we use as training areas. And then once we take those training areas, we move those into frequency space, and we find where the clusters of brightness values are of the pixels in the training areas. And once we've determined that we can do this and we can separate out the training areas in frequency space, then we can classify the entire image. So this is basically what we would do here. We would start with the entire image here, which is shown as this square outline. And then we would kind of put little polygons around the areas that we know. We know that this area is A, maybe that's water. This is B, maybe that's agriculture, and this is C, maybe that's rock. And then once we trained it in those areas and found out what the pixel values are, and of course we would use something here like one of those ISODATA or other sort of classification methods, then we can make a map where we say, yes, this everything in this area we know to be A, everything in this area we know to be B, and everything in this area we know to be C. So once again, we might start with a raw image, but we don't use all of the image initially. We don't put all of the pixels into frequency space comparing 2 or 3 bands as a scatter plot. We only take certain areas, like this area here, this area here, this area here, and we put that into the frequency space. And we might put it into a frequency space like this, and these might be the different categories that we're able to determine from two different bands, one for band 1 and the other for band 2 over here. And once we've done those 2 bands, then we can go back and we can look at all of the pixels shown in gray here, and we can categorize which ones are occurring where, and kind of expand those areas that we were looking at before, so that now we can apply the different categories or classes to the entire image. Again, one way we can do this is an ISODATA classification. This is only one of many ways we can do it, but we could use an ISODATA classification. So each one of these would represent a different class in frequency space. And then we could take all the known pixels that fall into these clusterings, and then we could assign that category to those pixels in our new layer, which is the classified image, the supervised classified image. So that's what we would end up with here. We would end up with an image, a classified image, in which all of the pixels are assigned to one type of land cover or similar throughout this entire area, not just the training areas. And so here we kind of expanded on that. We started with the raw data, right, which would be in this case 3 different bands of satellite imagery, one assigned to red, one assigned to green, and one assigned to blue. We've broken out the training areas. We've seen how the training areas cluster in frequency space. Then we've looked at all the pixels in the area, the training areas and beyond, and then we're seeing which of those categories that we defined by the training areas all of these other pixels would fall in, and now we have a classified map of the entire area, a supervised classified map of the entire area.